In this video I will go over the exercises that you have to do from the refresh of chapter 11, just in case you have some troubles with it or if you forgot how it works. Now, your homework for the refresh was exercise R4, R6 and R8. In the first two exercises you need to remove brackets. In exercise R4 you're asked to remove single brackets, and in R6 you have to remove double brackets. The book uses the multiplication table to do this for both types of brackets. I usually use arcs. It's up to you which method you prefer. Either one is just fine. In my explanation now I will use the arcs, and if you prefer the one the book uses, just read through the examples carefully. In exercise R4 I want to look at E, just for an example. If we want to write down this formula without brackets, we have to multiply. First draw two arcs, a short one and a long one, from minus 3e to e squared and from minus 3e to 3. These two arcs both represent a multiplication. So if I follow the short arc, I have to multiply minus 3e by e squared. Minus 3e times e squared, that's equal to minus 3e to the power of 3. Minus 3e times 3 then, if we follow the long arc, gives minus 9e. Don't forget to write down y equals at the beginning. This is the final answer, because these two terms are not like terms, so they cannot be collected together. In exercise R6 we have to remove double brackets. I've chosen F to look at with you guys. It doesn't look like there's double brackets here, but look closely. There's a square outside of these brackets. Squaring something means to multiply it by itself, so I have to multiply 3 plus 4n by itself, by 3 plus 4n. So I can write that formula without this square like this. Don't forget the last term, minus 3n squared. And now we do have a formula with double brackets. If you want to remove the brackets here in this formula, we have to make 4 arcs in total. 2 from the 3 to both of the things between the second brackets, and 2 arcs from 4n to both of the things in the second bracket as well. Just like in the previous exercise, each arc represents a multiplication. So just follow the arcs and do the multiplications. The first one from 3 to 3, that's 9. Then 3 to 4n. 3 times 4n is equal to 12n, positive, so plus 12n. Then over here, 4n times 3, that's the same calculation, so 12n again. And the last one, 4n times 4n, that's 16n squared. Don't forget to copy down the last term, minus 3n squared. Also don't forget to indicate that it's a formula by copying down z equals. Now the brackets are gone, but we can still simplify this formula by collecting together the like terms. Let's start with the highest power, the n to the power of 2's. If I take together 16n squared and minus 3n squared, I should get 13n squared. Then I have two terms with just the letter n. Both of them are positive, so 12n plus 12n, that's 24n. And then the only one that we haven't used is the plus 9. This is the ideal order, to start with the n squared, then the n, and then to end with a regular number. But if you have a different order, then that's correct as well. In any case, this is the final answer. In exercise R8, we have to solve equations. I talked about that a bit in the video in which I introduced chapter 11. These are equations that can be solved with the card method. So we're going to look at exercise E from R8 and solve that one using the card method. All of the other exercises from R8 work the same way. Now, the first thing that we have to do is decide where to place our card in this equation, and the only logical place would be here. So we can ask ourselves, what number squared is equal to 49? Now, of course, you're going to think 7, and that's correct, but there's another number. Minus 7 squared is also equal to 49. So we have to write down both of those options. Start by writing down whatever was underneath my card, p plus 3 in this case, and then the number that I thought could be under the card, 7. But the other option as well, so or p plus 3 could also be minus 7. So now we have two simple equations to solve. Again, we could do it with the card method. It's very simple. What number plus 3 is equal to 7? Can only be 4. And the other solution, what number plus 3 is equal to minus 7? That one is equal to minus 10, because minus 10 plus 3, that's minus 7. So these are my two solutions to this equation. And the other ones from exercise R8 work exactly the same way.